All right, welcome everybody. This is going to be part 2 of task 5, working on the NSA Codebreakers challenges. Just started the video back up from where we left off, or the recording from where we left off. If you remember, we're working on the Codebreaker challenge task 5, where we're trying to follow the data and enter the IP addresses trying to send data to. Based on that nomenclature, there's a good chance that after we had named the threads, that the upload thread is probably what we want to look at, as upload kind of implies a sense of this is what we want to access. So we can try to see if we can identify anything related to that. In the last part 1, we had started Ghidra analysis and had loaded up this binary into memory and I'd done a method to get some of the initial functions set up. After that, we were just going through naming the functions within what we thought was the main function, and now we're starting up within the threads. So, as I'd said, we're going to look primarily at the upload thread because this challenge is trying to find where we're uploading to, and this is a good identification of where that would probably be. So with that, we shall begin. Upload thread took a parameter. Looks like it's a long, or Ghidra is identified as a long pointer, but it's most likely a pointer of pointers of sorts, as that's how threading processes usually pass threads in, or arguments in a lot of times. Just looking through, we can see that we're accessing some variables or doing some sort of process with them. Looking through, you might not. We don't really see anything too spectacular. I don't think there's any system calls directly identified with this. A lot of very unique string or just data manipulation going on within here. There's a good chance this might just be string length of some sort or string compare. It's passing the parameter 0x3d, so that doesn't make too much sense for that. The second parameter in this function doesn't appear to be doing much either of use. But looking at these parameters, you can see that they're all capitalized and they appear to have some kind of value associated sent from lvar4. lvar4 appears to come from our arguments, so it looks like it's setting something in memory to something in memory. If you've identified these, the fact that they're all caps are kind of a hint to what they are, but we'll hold off on that for a little bit. It looks like we then call this function and then call exit, possibly. That might just be Ghidra misinterpreting it because we have some stuff right beneath it. That's interesting that the exit is sitting right there. Maybe this isn't actually exit then. No, that definitely looks like an exit call. Interesting, but we can also see that it appears to be calling fork at some point. So if ivar2 here's failed, so there's a good chance this is the fork. What just happened? It looks like I went into a side function of some sort. So I identified this as a function, and yet still shows up in here. Interesting. Oh, is this function? Nope. This one function calls dd. If we look back at our system call table, go down to dd. This is execve. Execve. So it's trying to run something in a new process. So that explains the exit at the end. So my new thought process is that this fork stuff is either not related or not important, as execve is probably the main point of this function, and Ghidra might just be misanalyzing this as being in the same process, as after this exit there's no return. I don't know if there's a way in Ghidra to specify this is the end of the function. Can we go to function? Doesn't look like there is, but that's probably what's happening, is that this is a completely different function, and Ghidra is identifying that there's an exit, but it's not identifying that it doesn't return, so it's like this function hasn't ended yet, even though there's just no return in this function. Should be able to say no return, actually. Edit function signature, no return. Okay. then do a reanalysis of this function. Function, recreate function. Yes. Did I click it? I might have misclicked it. Function, recreate function, recreate. Doesn't appear to have reanalyzed it correctly. Unfortunate. Yeah, I don't think there's a good way to do this then. I think the no return actually just specifies that no return happens within the arguments and not the analysis portion of this function. But we could possibly just come down here and let's do a little mischievous patch. See if this works. It might mess up because it's going to corrupt the stack, but I think that should be fine. It takes a little bit for the assembler to happen, but what we're going to do is, instead of these naps, we're just going to turn all the naps into return and see if that works. If this, there we go. I think a return instruction is a branch BR. Might be wrong. Just want to see a return. Oh, it's just return. Wasn't sure if the. Oh, don't. There we go. Return. And then if we reanalyze this function, where's the top of my function? Function recreate. Ah, you didn't reanalyze. Analyze stack. I could probably go to analysis, auto-analyze everything again. And that might do it, but it's also going to reanalyze the entire function, or entire program. So it's going to take a little bit. While that's going, we can just continue on. It actually might have worked by the looks of it. Yeah, sweet. So now we don't have to worry about looking at that fork stuff at the bottom. So, since we know that this is exec VE, yep, we can say exec, if we can grab it, exec VE. The parameters for exec VE should be the binary it's running, the arguments, and then the environment. Could take a gander at the environment, and it doesn't appear to be anything there yet. So let's actually just rename that to upload exec VE environment. Param2 and param1 are passed in. Param2 and param1 look to be the same, which makes sense because that's usually how it happens, but it's just a pointer, which happens from param1 at index 1. I'm actually going to change this from a lawn pointer to a void pointer. Whoops. Not the name, I want the type. Void pointer. It might not like that because it's going to try and dereference them, but in my head, a void pointer makes more sense, as these are probably character pointers if they're setting as strings. Probably set those as character pointers. Char pointer. Char pointer. Over 3. Char pointer. Oh, I didn't mean to set 3, I wanted 6. Char pointer. I'm not sure what 3 does. Elvar 3. Oh. It doesn't look like anything really. Let's just set to param1, the value at param1, which is probably a char pointer or some kind of double pointer. So it looks like we call fork. Our original one runs in a while true loop, probably grabbing data from some kind of upload location we haven't identified yet. And then the forked one comes in here, sets some data stuff, and then calls execve with parameters passed in the first argument. Or not the first argument, but like in parameters, but it's going to be index 1, because it's going to be +8, I think. Unless it's taking +8 param as a pointer already. I don't think it is. So lvar 18 is going to be a character pointer as well. And then we just had to identify what's being used within parameter 1. Looks like we have a length variable used here. It's identified as munmap, but that doesn't make too much sense with the fork being sent in. It looks like there's a syscall, which is 9D. Maybe it is just munmap 9D. No, that's set SID. Close, but not really. Set SID. Set SID takes 2 parameters. No, it doesn't. That's weird. It would appear. Did I look at the wrong one? 9D. Set SID. Move X8 9D. Interesting. I'm going to look at the 32-bit version just to make sure that it's not slightly different, which it probably will be, but if that makes more sense, it might be that. It shouldn't be, though. Schedule get scheduler. That one does take a process ID, which would be more in line with our fork, but still doesn't sound right. Set SID. What is a set SID? We'll take a gander at that. 9D, look at the man page for set SID. Creates a session and sets the process group ID. It doesn't take any parameters, so it's interesting why it's even sending. Maybe it's not sending them and it's just a it's just Ghidra thinking that parameters were there and it's identifying what was there. So if we edit the function signature and we just get rid of those two, might help us identify it better. Shouldn't make a difference, but it does, or it could. And it appears I didn't retype that to a character pointer. I just set that to a character pointer. We'll say binary. So it's going to be binary and the argument, or the binary itself. So with that set, there's a good chance then that this guy is actually going to be setting environment variables, and a good way to identify that is the fact that they're all capitalized, and that's how a lot of times they are used. Later on we can further or guarantee that these are going to be environment variables through other function usages. But first we need to try and figure out what binary is actually getting sent in here. So far we haven't identified anything. The functions here probably are just the data exfil ones. So it's going to be in a while loop here while some data exists or doesn't exist. And maybe we're reading data from a socket or something, or from a mutex, or we're setting a mutex so we can read it. Then we're unlocking the mutex. So this is kind of very, in a sense, what code will look like when you're trying to safely read data from memory or from some kind of process into memory to make sure nothing happens. Then we're just setting stuff. So it looks like as soon as data is actually found, we might go into the actual collector itself. Yeah, so we just need to find out what binaries get sent here, so we need to follow this upload thread arguments. Let's go back to main. Instead of clicking back, it'd be faster if I do this. Go back to main. Where are you at? pthread creates upload thread. So we're trying to identify what is set at pvstack1228. We could also just start this binary and run it dynamically. This might be easier. Well, if we follow pointer, looks like it's set to pointer. Pointer is set to 1080 possibly. Pointer plus 28 is SSH private key, plus 30 is the key file IPC. Pointer is then set down here to this value. Looks like 120, 218, 210 are set to dropper stuff. But if you identify and look closely, you can see that these are actually going to be right after or right next to this 1228. So there's a good chance that if this is an array of pointers, that this first one's just a pointer of some sort to these other variables, so the key file, IPC, whatever. Maybe it's a shared pointer between several of the threads. And then every other parameter would be the dropper exe, dropper config, dropper jur. And we can confirm that. We're going to run it in GDB just to make sure. Try and get out of this Ghidra view since it's really hard to see sometimes. If we try to run agent, it should ask for a config. I'm going to go in config and set this to 5, so it's, we're going to set to 0 so it logs everything. We're going to set daemonize to false. We don't want it to daemonize. A lot of these files shouldn't exist, so it might get angry. So let's actually change this up. I might need to copy over some of them from 4. Let's create a directory called private. Copy everything from 4 in USB x0. Should be all of these files. We don't care about the brute force stuff. I just didn't move them into private. ID, everything. ECC, everything into private. So go to private, should have those 4 files. So that should give us these ones. We just need to change this directory slightly. We'll do .. because we're just going to run this on our bare metal machine. I'm in a VM right now, so it should be safe to use or do in there. If you're concerned, you should run this in an actual VM or a secondary VM or something. Agent dropper is going to be in our current directory because we're already in agent. Temp dropper YAML works. Temp upload works. That just won't exist. Probably get angry about that. HMAC key does not exist yet, so we might have to create something there. Agent restart, whoops, will also be in our current directory. The collectors will also fail. I'm not going to try and emulate those. And I think that should be good for now. You could also spin this up within the Kemu image that they gave for task 4. We didn't even run it because we didn't need to. But other than that, I'm just going to run these all locally as the Kemu image we might use later, but it's not in use right now too much. So we can change back to agent. If we do agent config, this will run it, but we don't want it to run yet because it's actually going to do a Kemu arch64 on agent. On config, and what we want to do is do G1234 and connect GDB. Can't do just regular GDB since it's going to be an arch binary. We do multi-arch, and I'm going to have it load in the binary so it knows what kind of architecture we're working with. And target remote localhost at 1234, and we can see we instantly connect. Looking at Ghidra, we could set a breakpoint on where we actually care about. So we can probably want to stop at the pthread create function right here. So we're going to do that at 400,888. So break at *0x 400,888. Continue. And we can stop right here. If we press enter, it'll then try to spin up a pthread instance, which right now we don't want to do. But we can first identify what the arguments looked like in memory. So if you remember, the first one is probably a pointer to several variables or some kind of data structure that's passed between several different processes. And then this first one should be our binary itself. It looks like dropper is the binary, if we should be able to guess that. These other ones are just the YAML file, upload, other stuff that's passed in as well. So it looks like dropper is going to be our next identification and where we want to go. There's nothing else we really need within this Ghidra, within this Ghidra in that GDB session, as we just wanted to see what was passed into the parameters to make sure we were following the correct exec VE. So with that, I'll just close this one real quick. Kill this because I don't want this to actually spin up the threads and start listening and stuff. Wait, no, Ghidra dropper, spin that one up. I don't think we've done analysis on dropper yet. have that do its quick analysis. Now there's going to be a Go binary. So Go binaries are handled slightly different than just regular raw C files or regular Linux binaries. While it is still an ELF binary, the way Go is able to handle a lot of the data in the backend is different. We'll be using the new Ghidra version 11 this time, so the Go, I haven't seen the Go analysis and how it actually looks in this new one, but in the old ones it was a little bit hard to deal with, and we'll check to see how it works this time. Main is usually the first actual function. It's not done analyzing yet, but while it's analyzing, we can kind of look through it. It might change up a little bit. We can see that a lot is actually going on in this main, or appears to be a lot is going on. This could just be remnants of just Go internal garbage collection happening. But it looks like we actually have function names this time. It looks like it's still analyzing functions. But it looks like we can walk through. So it looks like it grabs the os.args and checks to see if, what I'm guessing, the args is equal to 2. Somehow Ghidra is either messing this up, but we need to have apparently 2 arguments. And we can run this real quick to identify that that's actually true. I have a lot of stuff open, so let me close a couple of them first. Clean this up. Close that. Don't need that right now. Firefox. Oh, I have 2 Firefox opens now. Oh, don't need the man page. Ghidra I want open. Don't need this terminal open. This is the one I want. So here, instead of running this, we might be able to run dropper, maybe tac help, see what happens. It looks like it's trying to connect to server, connected somehow, or loading that, and then so maybe it intercepted that tac help as an argument. So let's get rid of this. And it looks like it needs dropper and then a config file. So we got a access violation because it probably tried to read a file, tac help, but that file doesn't exist. Still going. So it looks like our first function that happens is it tries to read a config. We try to exfil connect, load x509 key pair. So it's crypto stuff. We read a file of some sort. Exfil connect it through TLS. Do a file path walk of some sort on the probably the system. We're doing a format string. Yes, I'm already there, but thank you. So this does look better than what it used to. It was the older versions were very troublesome, but format string, it's not identifying the string perfectly yet, but it looks like usage %s. So this is probably the fail state. So when we failed the config, so this probably just says config or something. So this one doesn't matter too much. We do care about these ones. So it looks like we're trying to read our config, but what are we trying to read from this config? So this is one of the configs we have no idea about. It's trying to do something in this config, which we know is a YAML file because that's what the config itself should look like. So it looks like the dropper just should be a YAML file of some sort, but other than that, we're not sure. So it looks like dropper config read file function 1. Blah, blah, blah. I'm not seeing, what I'm looking for right now is kind of unique functions. So like runtime slice or runtime make slice. Those are all garbage, so they're just internal. These strings, it's looking for a bzip2 reader. So maybe it's expecting our YAML file to be bzipped. There's a decode, so there's a good chance that it's expecting our YAML file to be bzipped. If we go into the decode, it's probably just parsing it. Unmarshal, nothing crazy in there. If we come out, go a little bit further, so compress bzip to new reader, so it's trying to bzip something there. Continue on. Oh, if that's just the same function we were already at. Looks like we have a read environment function. Kelsey high to low. If we just probably look that up, it's probably just an environment or a library to read environment variables. We can look through it to see if there's anything of use. Looks like we have some strings here. it's not actually going to convert them to characters for us, so I'm going to use binary or is it binary? No, chef, cyber chef. Gosh, I had a little brain forgetfulness there. So we can just dump that in there and say from hex true, so maybe just true. Copy this one. Check it out. True again. This is probably also true if we look at the 74, 72, 75, so it's probably just lowercase true. So that's all true. What's this one? It's probably false, false, false. So it looks like it's probably going through variables and checking to see if they're false or true. We don't know what variables yet, but we can maybe find those out. Parse error. Process field, that one's a new one, but it's looking like it's still from the same library. Those are TF01s, true, false. So it looks like it's just reading, oh, there's another function here that's unmarked, just creating a structure. So nothing crazy yet. So it looks like it's just reading in the config. I think that might be everything for this. It's probably another structure function. Yep, I've already looked at that. So let's go back, go back, go back, go back, go back, go back, go back. Let's go to exfil connect because that'd be the next one. Looks like we're actually doing some MongoDB stuff now. MongoDB is another database kind of application. It looks like it's using HTTP client with a URI, Mongo Connect, new database, new collection. So it might be of use to try and jump in around here and see if we can get there without having a valid YAML file and see what actually shows up. So let's see what happens if we say our YAML file is just empty. So we'll just touch log.yaml and we'll run dropper. We're going to run this in Chemu as well, but this time we're going to run dropper. I need log.yaml. Connect with GDB. GDB this time multi-arch on dropper. Run this. It really didn't like that. Oh, I can't run it. Target remote 1, 2, 3, 4. Okay, so it's spun up. We need to lower that. Set a breakpoint. It's called right here. It might not hurt to... It's interesting because it's saying that there's a possibility that this is actually called or just shows up first. But maybe the Go is just tossing it around randomly. So let's actually set a breakpoint right here at, I'm just going to copy that if I can, 381.264. Break at this address. Assuming that it's static, should set us there. It didn't like that. Oh, the YAML file failed. I don't think I have an example use case of a YAML file, so we can spin one up. So let's just go YAML example, YAML file. We're not sure what's supposed to be in there. We're not sure what it's trying to grab, so let's just create a generic YAML file. So can we just do foobar? We didn't see any strings on what it's trying to access, so maybe it's just loading all of the variables from the YAML file, and it just should know what's in there. Let's do foobar. If we remember, it needs to be gzipped. So gzip log.yaml. I'm going to copy this actually to backup back.yaml, and then we can do gzip log.yaml. So it should be log.yaml.gz. So now we run this on the .gz, connect this back up, continue. Oh, it needs bzip, not gzip. My bad. So we need gunzip the log, bzip to log. Try this one more time. I think it's going to change the name to bzip2. Target remote, continue. Create a new thread. Nothing's being printed, nothing's happening. So maybe that's good, maybe that's bad. Maybe it's stuck reading something. At this point, well, Control C sent in a connect to server. So it looks like maybe our thread disconnected from us. I think we might be able to do set detach on fork to off. See if that does anything for us. Doesn't appear to be, so we might just have to walk through it by hand. We can run this again. Connect. Our breakpoint could be wrong as well. Doesn't appear to be if we check out the instruction here. Looks like it should be at the exfil connect. Go back to Ghidra. Let's see if we can set a breakpoint at this read config here. So 380 FF4. Break at this address. Continue. Okay, we hit that one. I don't want to step in per se. Let's see if we can just step over. So either something might be wrong in our config, or it's just not loading it correctly. Maybe it just takes a little bit of time, as GDB might be just slowing it down. Possibly, maybe, no. Interesting. So it doesn't appear that methodology will work too well. We could try stepping through the read config, see what happens there, but I don't think that'll really do much different for us. We still need to find a way to get to this exfil connect. Possible that this is occurring because the Chemu system or the Chemu instance doesn't handle threading very well, and Go loves its threads. So there's a couple options that we could go about this. One, we could do this all statically, see if it's accessing anything. So it looks like it's failed to connect to MongoDB. So we know the string connecting to server, it gets printed at some point. So if we can find that. Connecting to server. Try and identify where that's happening. That might be one path. Control. Let's go to search. Program text. Nope. Search. Memory. For this. Oh, didn't like that. For this string. Sorry if you guys heard that as well. It just beeped at me when I tried to paste. Search. It finds this string right here. Dismiss. We can go to the reference. Looks like it's a pointer. It's referenced within main. Happens right here. So it looks like this is the connect to server string, which makes sense if this right here looks like logging output. Looks like it's probably going to log this connect to string right there. Main print function 2. That's just another function. I think within that. If we follow this down, it should try to load this X509 key pair first before exfilling. So it's weird. Unless it drops down. Yeah, it just jumped down. Interesting. So if logger output, so let's set a breakpoint around, what's this string? It's just probably how many characters that this string is. Should be, nope, that's 17. Let's try setting a breakpoint right after this read config, and see if we can get there. If not, we might have to go through route 2, which would then also mean a part 3 to this video. So let's go back to this Kemu, set the target, break at this address, continue, continue. Yeah, I would have to guess that it's not liking the threads very much, because the process for threading within Kemu I don't think plays nice with remote GDB instances. We can try deleting 2 because maybe the breakpoint breaks it. So it does say it creates a new thread. It doesn't look like we hit. Okay, so with that, we'll have to probably go into a part 3, and then in part 3 we'll finally find a way to walk through this in GDB. Thanks for watching.